Special right triangles, and we're going to focus on the 30, 60, 90 triangle and the 45, 45, 90 triangle. And what we've decided is if you have a situation of angle, 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 that means triangles are similar. Well, that just means that every triangle that has 30, 60, 90 degree angles, they're all similar to other 30, 60, 90 triangles, which means their sides are in the exact same proportion. This is a really nice triangle because it has a pattern that's pretty easy to memorize. So I can take this, and again, I can move. Thought I could move. Oh, I can move B. I can move it in anything I want, right? This is always 60 degrees, up, down. And again, I'm saying that this triangle and this triangle and this triangle and that triangle are all the same triangle. Now, they're not congruent, of course, but they're similar. Their sides are in proportion. And it turns out that they have a very nice pattern. It's 1, 2, radical 3. And that means is that whatever this is, the hypotenuse is double for all 30, 60, 90 triangles. And the green one, it's a little tricky. That length is the square root of 3 times bigger than this one. So let's go ahead and show these lengths. And we know that I'm going to make that, let's make it 2. Well, you know what? That's pretty small. Let's make it 3. That is really, can I get 3 exactly? Oh, that little turkey won't let me get 3. That is touchy. Okay, so let's pretend that's 3. Well, if that's 3, that is exactly 6. In this case, it's 2.99, but double is 5.98. And again, it doesn't matter what I do. As long as it's a 30, 60, 90 triangle, the short leg, which of course is adjacent to the bigger angle, the 60-degree angle has the short leg next to it. That is always a 1-to-2 ratio. And this isn't as obvious because the square root of 3 is some, irrational number, really close to 1.73. But if you take 3 and you multiply by the square root of 3, you're going to get this length. And again, if I change this to something close to 4, I get exactly 8. And then I get exactly 4 radical 3. This is the pattern. And again, it doesn't matter how it's oriented. The 60-degree leg is the short leg. If I make that 8, I thought I was going to go to get 8, really close to 8. This is going to be 16. It always is that. Again, every one of these triangles is similar, which means they have that same proportion. Okay? So let's get rid of that triangle. Again, that pattern is well established. I'm like, well, what about this triangle? Well, check it out. If it's a 45, 45, 90 triangle, and these two angles are always 45, well, that means it's an isosceles triangle, which means these legs are always the same length. Well, of course, they're both 45-degree angles. It doesn't matter what I do or how I orient it. If these angles are 45, it's isosceles. These two are the same. Well, it turns out that the hypotenuse is the square root of 2 times bigger. So if this is 6, of course this is 6, and this is 6 square root of 2, meaning 6 times the square root of 2. 6 times the square root of 2 happens to be rounded to 8.49. Remember, the square root of 2 is like 1.41 in terms of a number. So if I make this 1, look, 1, 1, radical 2. Radical 2 as a decimal is close to 1.41. It has to be close because it's irrational. I can't express it as a decimal. Okay, it's the whole point of being irrational. It can't be a rational number. And again, it doesn't matter. I always get some isosceles right triangle. And these two legs are the same, and the hypotenuse is the square root of 2 times bigger. Okay, so those two patterns, again, 1, 2, radical 3. The hypotenuse is double the short leg in a 30, 60, 90. The long leg is the square root of 3 times bigger. And for a 45, 45, 90, you have the legs are the same, and the hypotenuse is the square root of 2 times bigger. Well, what happens if you were given the hypotenuse? Well, couldn't you just divide by radical 2 to get the short legs? And you're like, sure, right? Multiply to go this way, divide to go that way. Same thing. If you had the hypotenuse was whatever, you could divide by 2, meaning find half of it to find the short leg. And once you know the short leg, you can multiply by the square root of 3 to get this. These two patterns, the 30, 60, 90 and the 45, 45, 90 are the two patterns we're going to explore. And again, I'm going to go over to the sheet now and explore on that. So, all right, let's go through special rights again. This is coming from the video on GeoGebra, but these are the patterns, right? If you have a 30, 60, 90 triangle, every single one of those, whether a big one or a small one, have this same pattern. The short leg is half the hypotenuse, and the short leg is the square root of 3 times the short leg. For a 45, 45, 90 triangle, the legs, of course, are the same, right? Because the angles are the same. And the hypotenuse is the square root of 2 times bigger. Now, if you look at it in some textbooks, they might say, like, this is x down here, and this is the square root of 3 times x, and this is just 2x. And then x can be whatever it wants. Let's say x was 5. Well, this would be 5, this would be 10, and this would be 5 times the square root of 3. Same thing here, x, square root of 2x. Just kind of notation. I don't know, I mean, obviously the x can be there or it can't be there. But again, these patterns you have to memorize, and all it's saying is that all 30, 60, 90 triangles have the same pattern because they're similar. So the hypotenuse is double the short leg, the long leg is the square root of 3 times the short leg. Same idea for this guy. Right? For all 45, 45, 90 triangles are similar. Their hypotenuse is the square root of 2 times bigger than the short leg. All right, let's do some problems. So if you are given this and you wanted to find everything else about the triangle, well, first, once you see this is 60 and this is 90, you know that top angle is 30. So that means you know you're dealing with a 30, 60, 90 triangle. The 60-degree leg is the short leg. But if I have the short leg, all I have to do is double it to find the hypotenuse. And all I have to do is multiply by the square root of 3 to find the long leg. And if you wanted a decimal, you could use your calculator. Okay, let's do this one. Once I see that's 30, this is the long leg, this is the short leg, and of course that's the hypotenuse. And I know for all 30, 60, 90 triangles, the short leg is half the hypotenuse. So just take that hypotenuse and divide it by 2 to get the short leg. And then once you get the short leg, you can multiply by the square root of 3 to get the long leg. Okay, now this next one's the harder one. So it's easy if you're given the short leg or you're given the hypotenuse. What if you actually have the long leg? Well, what did we say? The long leg is the square root of 3 times bigger than the short leg. So if you were given the long leg, can't you just divide by the square root of 3 to find the short leg? Sure. So this is the length of the short leg, and unfortunately, math people want us to rationalize this. So we're going to multiply top and bottom by the square root of 3. And that gives us 6 square root of 3 over 3. 6 over 3 is just 2. So I know that that is 2 radical 3. And then how do I get the hypotenuse? Well, the hypotenuse is double the short leg. If I double that, I just get 4 radical 3. 4 radical 3 is twice as big as 2 radical 3. So this is the hard one. Those are kind of easier. How about this one now? Now all of these, see how these are labeled as the same angle, which means those sides are the same, which means it's a 45, 45, 90 triangle. So if that's 3, that's 3. But if that's 3, that's 3 radical 2. Because I know the hypotenuse is the square root of 2 times bigger than the short leg. All right, now this one. All right, this time I'm given the hypotenuse for 45, 45. Well, can I just divide by the square root of 2? And you're like, sure. 20 divided by the square root of 2. Well, I have to multiply top and bottom by the square root of 2. And that's going to give me 20 radical 2 over 2. But 20 over 2 is just 10. So I get 10 radical 2. But once I know 1, well, I know they're both 10 radical 2. Okay? And then how about like a small application? All right, this is a square, and we know that a square is a 90 degree, and we also know that a square is this. So that must mean that the diagonal here breaks it up into a 45, 45, 90 triangle. So if you know that that's square root of 3, don't you know that that's the square root of 3? And then don't you know that that is the square root of 3, and the square root of 2 times bigger? Square root of 3 times square root of 2 is the square root of 6. So the diagonal here would be the square root of 6 long. You know, there are more examples we could do, but that kind of gives you the basics of certainly we have two main patterns. We have a 30, 60, 90 pattern, and we have a 45, 45, 90 pattern. You got to memorize those, right? These are the two harder ones. If you're given a long leg, you end up having to divide, and in 45, 45, 90, if you're given the hypotenuse, you end up having to divide. But really, dividing by a radical 2, we just multiply top and bottom by radical 2, and then, we simplify. Same thing here. Divide by radical 3, rationalize it by multiplying top and bottom by radical 3, but all we're doing is getting rid of the radical in the denominator, and then simplify if we need to. Once you know the short leg, of course, then you can just double to find the hypotenuse. Is pretty easy. Okay, hopefully this video helps you get started on special right triangles.